Hi there, I'm Lean, a solutions marketer at NI focusing on production test. And today I'm talking about NI's battery cell quality test solution. Regardless of your field, whether it's in electronics, medical devices, or EV applications, if you need to test batteries before integrating them into your device or vehicle, this video is for you. Batteries are becoming more and more common in our society, from the rise in electrical vehicles to the ability to move patient devices across hospital rooms. And when it comes to devices like glucose monitors, you can't compromise on the reliability and accuracy of those battery cells. So basically, you need to test faster to meet demanding production volume without compromising on quality, and you need to be able to quickly adapt to new changes. This is where NI's battery cell quality test solution comes in. With this solution, you can perform different tests like open circuit voltage, AC internal resistance, electromechanical impedance spectroscopy, leakage, and capacity in a high-precision, small form factor PXI system. If you're familiar with PXI, here we have a system with an embedded controller. So this right here is basically a computer that's running everything. We have a DMM, which performs fast and precise voltage measurements with the highest accuracy and precision on the market. We have an SMU for precise measurement and current sourcing for the ACIR, EIS, leakage, and capacity tests, and even an LCR meter for higher frequency EIS tests up to 2 MHz. We also have a multiplexer switch module to amplify the number of our channels for our measurements. So this system, for example, lets us test 54 batteries. So let's see a couple of these tests in action with the LabVIEW program that we've prepared. I am testing only the one battery today. First, we'll start with the ACIR, or the AC internal resistance test, which is one of the most common and better known battery quality tests. So ACIR evaluates the impedance of the battery under alternating current flows at a specific frequency, typically at 1 kHz. By analyzing the response, engineers can characterize the AC dynamic of the cell and detect critical defects. To put it a little bit more simply, if there's additional internal resistance from within the battery and it's discharging extra when it's not supposed to be when it's connected to a load, that will be affecting the way that it performs. So I'm going to run the test right now. It's going to be very quick because it's just the one battery, and here we go. You can see here we get the resistance result. I'll run it again. This is a pretty good resistance to have. So we have a pretty okay battery. The second test that I want to show you is similar to the ACIR, but instead of being at one frequency, it sweeps through a range of frequencies. And before I run it and talk about it a little bit more, I wanted to show you a ready plot. So I ran it before, just because this will take around 2.5 minutes to run. So here we have the plot where you kind of see the sweep of frequencies, and we also have a Bode plot where you can see the magnitude and the phase. So let me run it so you can see it in action. It's going to clear the plot and start from scratch. There we go. And I'll give you a little bit more information on it. So the EIS test is the electromechanical impedance spectroscopy test. These tests are the most advanced type of impedance test. So like I mentioned, instead of applying the sinusoid at one frequency, like the ACIR test does, the stimuli are applied at many frequencies, typically from 0.1 Hz to 10 kHz or more. What that does is it helps you gain a comprehensive understanding of the battery's internal dynamics and deeper insights into the battery's behavior. So defects that would otherwise go undetected by the ACIR test are captured with EIS, things like premature aging. And like I mentioned, this test does take a bit longer, so it might not make sense for you to always run this test. But once you test a batch of batteries, you can start to look for where the batteries are showing signs of failure, and then you can go back and do ACIR measurements at those specific frequencies. So if you need to test batteries in volume, adapt to changing battery needs, and you really can't compromise on end quality, NI's battery cell quality test solution is worth checking out. Thanks.